Welcome to the second part of the tutorial. So in this part we will have a quick introduction on the main concepts that are going to be developed later on. So I will start describing what are data and metadata in material science, and then I will keep going with describing how do we usually try to structure this data into base sections or base classes. And I will also show the several ways we have to implement this structured data within NOMAD. And then I will leave the space for the upcoming hands-on tutorials. So in material science, we usually have three main sources of data. This can be the raw data coming from the files that are being generated from the instruments where we perform experiments, or we can have some ELN data that are essentially manually recorded part of information. And we also have data analysis kind of data that is coming from the post-processing software, or maybe from user-tailored scripts that are used to post-process the data. What we essentially do is to combine all these pieces of information into a unified data model that consists in describing each part of the information and also clarifying the relationship between each of these parts. So before going on, I will just explain which is the difference between data and metadata. As you see here, the data are the actual content of information that we extract from an experiment, while the metadata are other kind of data that provide a context about the main ones. There are several kinds of metadata. One of them is the structural metadata. And as you see here, structural metadata can be, for example, the description or the unit or the type that we are sticking to each of these arrays here. So to clarify the context and to explain better the nature of this source of data. Also, whenever we upload an archive or we generate an archive file in NOMAD, there is a handful of metadata that is stick to that, and this is just all of them are used for formal data management purpose. Another kind of metadata is the descriptive metadata. So these kind of metadata contain actually some scientific information. As you see here, I left some questions. And so the answer to this question are examples of kind of metadata that we may want to add to complement our data from experiment. This can range from the specification of the instrument to clarifying which is the history of the specimen that has been measured, or other kind of questions like this. Okay, so I will show how do we structure our data and how do we generate these base classes or base sections. You see here an example, a schema of a vapor deposition instrument, where essentially there are some gas lines that are carrying some precursors in the reaction chamber, where then the deposition takes place. So you see here that we generate some classes that are trying to cast each source of information. And for example, we have chemicals that are used to describe the precursors, or we have sources. In this case, these are bubblers. There can be many kinds of sources. Or we also use classes to describe the final sample that has been produced. So these classes are meant to be general enough to be used also outside the specific experiment. So they are generated from one, but then they hopefully would acquire more generality to be shared among different experiments. And indeed, what we do with these classes is essentially an object-oriented kind of approach. And indeed, there are two main concepts connected to the object-oriented programming. One of them is the inheritance. Indeed, as we see here, we can have a general class such as instrument, and then we can describe some properties in this class, and then we can create a subclass that is inheriting from this one. In this case, I generated here my Gauss meter that can be an instrument that I have in my lab. And so this one is inheriting from the instrument, and so we'll have all the properties already included in instrument plus the ones that I am specifying. Another important concept is the composition. So let's take the case in which we have the experiment class. We can think to compose inside this experiment class as many other classes as we need. For example, an experiment we can imagine that can need inside composed like an instrument class or a sample class or a user or other kind of classes that could be useful. What do we do with these schemas after we generate them? So we have this blueprint describing our structure. What we can do is to generate a template that is an empty file that is structured on the shape of the schema that we decided. So what will happen is that after generating the template, we can actually fill it with data, and we will show during this tutorial a couple of ways about how to fill this template. One is the manual way with the ELN, and the other one is like an automated way coding some kind of processing that will be wrapped in a plugin as showed later. So after defining our data model, we can go on and think to develop like tools within a platform that in our case is NOMAD, and these tools are benefiting or exploiting the structure we defined, and they can enhance searching features or visualization or even automated post-processing or analysis features. So actually, when dealing with the research data management, we do not always have a perfectly structured data, especially at the beginning of this kind of work. And indeed, that's why here I showed for 5 different levels of structuring. So as you can see, the first one, the level 0, is just having unstructured data. In this case, we just upload somewhere our data without any kind of metadata extraction. And some example of this can be like, for example, Zenodo, or maybe even NOMAD, whenever we do not have a specific processing of our files. So this is just about uploading. The first level of, let's say, structuring efforts would be to use these built-in classes that are available in NOMAD. And this is a kind of quick solution, and one can exploit the general classes that are made available in the ELN functionality of NOMAD already. Whenever these classes are too general and they cannot really enclose all the needs of a specific lab, we can go and customize these available classes. So one way is to write a YAML schema that is inheriting from the built-in classes and extending it depending on our needs. Or a more powerful way would be to write this schema basically in Python code, and we can also stick to this schema a kind of a post-processing or automated analysis or parsing of metadata from some raw file that we may have available from some experiment. So when this plugin, let's say, acquire more generality and they are shared by different labs or institutions, they can be called community standard plugins, and we have some of them that I will show you later. So this first part, level 1 and 2, will be shown by Sarthak in the next part of the tutorial, and then we will have also Hampus showing us how to deploy a plugin. I will also show you the GitHub repos that one can go and check for the community plugins that we have available. Okay, so the main data model that we have is based on entity and activity concepts. So all the data arising from an experiment can be cast in one of these two main concepts. You see here already some inheritance tree. So for example, an entity can be either a system, that is the sample that we generate, or an instrument, and an activity can be of several types, can be a process intended as a synthesis process, or a measurement, or maybe some post-processing analysis. We also have this experiment class, That is something that Sarthak will show in the upcoming part, and this is the general most file that we can generate. We will see how this process, measurement, and analysis will be just structured as steps of this experiment. This is the next level of structuring. So you see here a YAML file. A YAML is just a kind of markup language. And in our case, this is just constituted by three main parts. So as you see, the blue circle one is the name of our custom class. So we decide is user defined. And then we have essentially three subsections. So they can be base sections where we list all the inheritance that we have in our defined class. And then we have quantities where we write these data fields that we want to extend the classes with, and subsections where we compose other classes inside when needed. For a better understanding of this, you can check out also the tutorial 8 in the YouTube channel, and we are going in more detail in the explanation of how to build such kind of YAML schema files. What is now the point is about plugins. So which is the main feature we get when using a plugin is that we can stick, as I said, some automated processing. So in this case, we can drag and drop the raw files in our ELN and get some automated processing. This means that the archive files are automatically created, and the metadata is extracted from the raw files and filled in the archive files that we created. As you see here, this is an example of in situ reflectance in which we are analyzing the signal and picking maxima and minima and then calculating the growth rate in this case. So this means that the figure of merit of an experiment can be automatically extracted without any user effort needed. Okay, so you can check the tutorial 12 for a better explanation on which are all the features or functionalities that we can think to code within a plugin, so to have a better understanding of the plugin development. And what will happen in the subsequent part of the tutorial will be, let's say, a showcase of how to deploy and really start using your plugin. So it's not about the functionalities we can code, but how to really make it to work. And this will be shown by Hampus later. Last thing I want to leave in this part of the talk is the links to the community plugins. I think they will be found also in the comments below. And so there are essentially three community plugins. One is connected to the classes for the synthesis processes. One is containing the classes of the characterization kind of measurements we may want to perform. And the third one contains the framework to start making some post-processing or analysis on the data. Okay, so thank you for the attention. I will leave now the screen to Sarthak that is gonna show us how to work with the ELN. Thank you.
Great. So thanks, Andrea, for a beautiful explanation and an introduction to the base sections and the level of schemas. But in this demo, I will go through the built-in schemas, which are indeed inheriting the base sections. And these are like the out-of-the-box solutions, which you can directly use in NOMAD to structure your experimental data. So we'll see how to use them, and we'll start with an example of a sintering experiment, and we'll explore multiple built-in schemas to capture different aspects of the experiment. And after this, we will also take a look into how to use a custom YAML schema, and to use it to extend the base sections to have some additional quantities. And we'll see how to just simply use them, not write these schemas, but how to use them. And then in the end, we'll quickly take a look at one of our community plugins, which we developed for XRD measurement data. And we'll see how to, you can actually enjoy the automation of a plugin. Yeah, so that's a rough outline, and we'll dive right in. The prerequisite would be, of course, a NOMAD account, because we'll be working with the example OSs. So if you're already on this GitHub README page, we are in the tutorial 13 part 2 README, and you can actually access the link for the example OSs. But if you are not there, if you happen to be on the landing page of Nomad, you can just simply scroll down and you will find the example OSs link here. And upon clicking it, so you might have to create an account with Nomad if you don't already have one. But because I already have some, the account, I'm already logged in. And here, the first step to do anything in Nomad is to create an upload. And upload is more of a container which will, contain all the entries that you create. Or if you are adding some raw files, they will also they'll also be stored in the upload. And once the upload is ready, you can actually publish this upload on the global database. And to do that, we'll go into the publish and we'll select the upload here. And then we can create an upload, and maybe we start with naming it something. Let's say tutorial 13 demo part 2, and we hit save. So now the upload itself is ready, and you can start adding some entries based on the built-in schemas. And let's start with the creation of an ELN, or an electronic lab notebook for the experiment. And we go in the create from schema button, and we select the built-in schemas. And here we can actually select one of the basic ELNs, which is the experiment one. And maybe we name it as my centering experiment. And we hit create. So what it does is it creates an entry in the current upload folder, and it directly takes you to the data section of this entry. And as Andrea already explained, there are two types of things that you can have in Nomad. One is quantities, and the other one are subsections. And the quantities are the places or the fields where you actually store the data. Whereas subsections allow you to nest more sections within a parent section. So you can put some nesting in your data structure by adding some subsections. So if I was to open this experiment identifier subsection, I will see that it has a bunch of more quantities defined within it. So the data section, the data tab here, if we just take a look at these 4 tabs in the top, the data tab actually allows you to interact with all of these quantities and all of these subsections. But if I was in the overview tab, I will only be able to interact with the top level quantities of the data structure, which include the name, starting time, and description. And of course, these quantities are directly inherited by the process-based section, or sorry, the experiment-based section that is behind this ELN. And if we go down in the overview tab, we also see a workflow graph, which is right now empty because we really don't have anything in this schema. But we'll come back to this again. And another tab is the files. So it allows you to actually see all the entries or the raw files that are available in the current upload folder. And right now we only have the experiment, the centering experiment entry that we just created. And we also have a logs tab where, if there are any errors or warnings related to related to the processing of these entries in Nomad, you will be able to see them here. So this is more for debugging. And we really hope that you don't see many of the errors here. But let's go back to the data section, and let's start populating our experiment ELN. Starting with the description, maybe we can say experiment. Wait. Yeah, so maybe we want to add some information related to this experiment, which includes the centering process itself and some XRD measurement that we do on the centered sample. So we can go ahead and save this entry. And if we go down and now we actually start creating these steps of the experiment, and we see the step subsection, we hit the add button here, and this creates an experiment step, and we name this first step as centering. And now what we do is we will create another entry related to the process ELN, and make a reference to this entry here. And all of this thing can actually be done by simply clicking on this add button, and we can select what is the target upload, which is the current upload folder that we want to put our entry in, and we select the inheriting section. So basically what kind of base section or what kind of class you want to make this entry out of. So we'll select the ELN process. There are a bunch of them, but because this is a centering process, so let's go with the ELN process and name it as my centering process. Okay, and we hit save. So if we go into the files, and maybe if we reload this, we can see that our centering process is created. So there is another entry in the current upload folder. And yeah, so let's go back to this entry again. So there we added our centering step, and we can also use this small arrow button to actually take a look at the summary of this section. And if we go and click on this right arrow button again, we'll actually be taken inside this processing ELN that we just created. So we are in the overview section. We toggle into the data tab and we go into the data section. So here we can already start populating the the data related to the centering process itself. So you can of course fill these quantities, the general quantities like the starting time or the ending time. But let's just start with the description. Let's say that the centering step includes two steps inside it, which is heating and cooling. And we hit save. Yeah, and then we have a bunch of
Sorry,
subsections here.
where do you hit save? Like, how do you save that?
So the save button is here. I mean, if I have something, if there is something to be saved, the floppy kind of a button here, save entry, which says save entry, we just simply click it and it saves
thank
it.
you.
Yeah.
And also one further question. So when you created this additional step, would you clicked somewhere on add and then this JSON file was created? I did not see where you clicked. So when you were in this.
Yeah, so I was in the experiment and I created the centering process.
Yes. And where did you click?
Yeah, so
steps and then on the right.
I had to click on this. Yeah. So do you mean this little add button here?
Yeah,
I
don't know. I was working on my screen and you were saying you click on add and then I could not see where you clicked, unfortunately.
Okay. I'll try to be a bit slower then. Yeah. So you just simply click on this add button on the
this is add. Okay, yeah, sure. Yeah. Okay. Yeah, no, I got it.
Yeah. And all right.
Thank you.
Then we go inside. No issues. We go inside the process and let's try to populate the process that we just created. And inside, I mean, if you're ever lost, in this navigation, you can totally go back into the upload folder and you can select the entry that we are working with. So right now we are working with the process entry. So now we go to the data section again, and we scroll down and we add a step inside the centering process. So let's start with heating. And let's say that the duration for this step is around 30 minutes or exactly 30 minutes. And maybe we started this step today at 10 in the morning. And we use the comment section to add a bunch of more data, like the initial temperature. We started at, let's say, room temperature, and we have the final temperature as 100 degrees. Of course, all this data is quite fictional, so let's not really think about the data much. And similarly, we can also, click on the add button again and create another step and name it as cooling. Let's say that we cool for 1 hour, and we start it right after the heating step, so 10:30. And here again, we want to add initial temperature as as 100 degrees, and the final temperature as the room temperature again. And we hit save. And of course, you can already understand that there is this limitation where we could even put more structure to this data, but we don't have these quantities available with us right now. And we'll come back to this again when we talk about the custom schemas. But for now, let's save these steps that we created. And now let's go into the samples subsection and create a sample. Again, we are going to do the same thing. We will create another entry for this sample. And we will generate a reference for this entry in here. And we can do this by clicking on this add button. And it again asks us the target upload, which is the current folder. And the inheriting class, let's select the ELN sample. And let's name it as my sintering sample. And hit create. And we save it. So once you have saved it, we can press this little right arrow to actually take a look at the overview of this sample ELN, and we could also press again the right arrow again to actually go inside this sample ELN. So there are multiple ways of navigating between different entries, and I'll try to show you most of them. But now we are inside the sample ELN, and let's go into the data section here. And it already has the basic base section kind of a structure, like inherited from the base section. But if you go into the subsections here, you'll find there is elemental composition, which you can add, which you can use to add elements which are available in the sample. Let's say that this sintering sample is actually nothing but gallium oxide. And hit save. So here we could actually go ahead and use the elemental composition subsection to add gallium and oxygen. But rather than doing that, we will actually let's explore components. And because gallium oxide, let's assume that this is a pure substance, we'll select the pure substance component. And we also get this pure substance as a subsection here. And we go inside. You might be wondering why I'm doing all these stuff, but very shortly. Okay, so now we select the PubChem pure substance section, and we will add the name of the substance as gallium oxide. So what it does is, like, we have some automation put into the sample ELN, where if your substance is a pure substance and if it has some information available in one of these databases like PubChem, you could actually simply put the name of the substance and hit save, and it will actually get most of the information from that database and fill the entries. And that is exactly what happens here. And if we start going back into the root, we'll see that the elemental composition is also already populated. And this is like one of the automations that we have here. And when Hampus explains how to build more plugins, building the plugins is all about making these automations inbuilt into your ELNs. But yeah, so let's say that that is all we wanted to add into the sample. And we go into the files and we go back into the process. Cool. So until now, when we created the process, we started populating it by adding the description and then the steps of the sintering and the sample. And if we go to the workflow graph, you can see that there is a nice visual summary of all this thing that we just did already available. So heating and cooling are the steps inside the sintering process, and there is a sample associated with this. Right now, it does not make a lot of sense because we are not really creating a sample, rather than we are performing some action on that sample. So having this as an output is not very ideal. But this is, again, the base behavior of this class, and we can change this if we are writing our own plugins. But now let's go back into our experiment. So we created our process within the experiment, and let's create another experiment step, which is related to the XRD measurement. So yeah, that's the sintering step. And let's add another step. And we go into the second step here. And let's name this as XRD measurement. And again, we will create an entry for the measurement ELN, and we will reference it in here. So we repeat the step, but we select the inheriting class as ELN measurement. And let's say my XRD measurement. So similarly, we can, again, hit save. Yeah, saving after every step is super important, because otherwise it might end up erasing the stuff that you just did. So we save it, and we can explore the measurement ELN. And if we go inside the measurement ELN, we again have these general quantities. If we go into the data, we can actually see all the quantities along with the subsections here. And now let's say that we start with filling the description. Let's say that this includes XRD pattern from the machine, and that's all we want to add here for now. But before we do that, we could actually add the sample. And this time we don't have to create a new sample because we already did it. So rather than clicking on this plus button, we will use the second option, which is an edit or search for the reference. It's a small pencil, and this opens a search menu, which allows us to search for the sample, and we can limit the search to only this upload. And that's the sample that we created, my sintering sample. So we can select this, and it will take the already existing entry and create a reference to that entry and save it. And then maybe we can add the result. Let's name this result as XRD pattern. And so this is a rich text field. You could add the text. You could also, format the text, but we can also add an image here. So let's go and insert an image. Go into the upload, browse for an image. And this image is available in our GitHub repo. And we just upload it. So that's a linear plot of 2 theta versus intensity. And yeah, we hit save. So we, as for now, in the measurement, we simply added the sample and we added some results. Now, if you go into the overview of this measurement and go into the workflow, we can again see a nice visual summary. The sample goes in and the result comes out of this measurement ELN. Yeah, so good so far. Let's go back into our upload folder. And now, just as a recap, we started with the experiment, we created the process. Inside the process, we created a sample. And then we again created another experimental step, which is the measurement. And then we reference the same sample inside the measurement. And this summary is also available in the overview section of the experiment. And if you go in the workflow here, you can see that the sintering experiment includes these 2 steps, the process and the measurement. And you could also click on them and actually look into what is really happening within these experimental steps. And similarly, you could also go inside the measurement and have a good visual summary. Yeah, so that concludes our first part of this demo, which was simply using the built-in schemas. But let's now also talk about how you can use a custom YAML schema to actually add some additional quantities on top of these base sections. So for this, I will simply drop a schema file, which is again available in the GitHub. It's under the files and custom schemas and sintering.archive.yaml. And now when I upload this file, the Nomad reads this YAML schema and it creates an entry of type schema. So this is also the same schema that Andrea showed in his slides. And now we can actually see how Nomad really processes it. So let's go inside the schema. And you can see there's a temperature ramp section and there's a sintering section. And if we go inside sintering, you can see that the base section for sintering is, the base section for sintering is the process, like the process base section, which we have been playing with so far in our basic ELNs. But if you go into the steps here, you can also see that the steps is overwritten. And if you open the steps, you can find that 4 of these quantities are inherited, but there are initial temperature and final temperature, which are the quantities added on top of the inherited quantities. And this is exactly what we'll fill now. So we go back into the upload folder, and now we create another entry. Let's say my better sintering process. And rather than selecting a built-in schema, we'll select a custom schema. And we limit our search to only this upload. And we can see the schema that we just added is available here. And here we select the sintering class. And we hit create. So now we have created an entry based on this new schema, which has these additional quantities. And we can take a look at these quantities by going down and adding a step. And now, now we have some initial and final temperature quantities here. So you could, in principle, repeat the stuff that we did. If I remember correctly, it was 10 that we started our heating step. And the initial temperature was 25, the final temperature was 100, and the duration was 0.5, so around 30 minutes. And we can hit save. So now, rather than adding this information in the comments, we have dedicated quantities where we can save it in a more structured way. And you could go ahead and populate this process even further the way we did before. But yeah, I would like to stop here for the second part, which was how to use a custom schema. And I'll quickly show you the third part of this demo, which is about using one of the plugins. Now, maybe you have
excuse me.
an XRD.
May I ask a question? Because I wanted to ask, when you are creating your scheme, and then you're uploading, for instance, like an image as you did it, but how do you upload a file? So HDF5 file or whatever, and then as like shown in the introductory slides, that you then are able
Exactly,
to also extract the metadata and display it and so on and so forth. But this maybe will come later, or
right. This is right about now. So
okay. So thanks.
So this is exactly what I will explain in part 3 of this tutorial. So then I will show how we can develop a plugin where we can really do this to a custom file and read it and so on. So it's to come.
Yeah, exactly. And I'll show a little glimpse of what a developed plugin would look like. So maybe you have a file, an XRD file coming from an instrument, and we could actually write a plugin which would, when you drop this file in this upload folder, it will actually parse this file and extract the data and the metadata from this file. So right now we have one of this plugin already implemented, which is for XRD measurements specifically, and we'll see how we can use this. So let's go into the files on the GitHub repo again. And inside the XRD files, there is a Rigaku file with the extension .rasix. And if you open this, it will upload the file in the upload folder, and it will do some processing. And now it created basically, let's say, expand this list. So it creates 2 entries, and one of them is this ELN X-ray diffraction, and another one is raw file. So the raw file simply creates a reference to the to this XRD raw file, but more interesting for us is the ELN X-ray diffraction. And if you go into this entry, we can see that there is a schema, and the schema is already populated with the information that was grabbed from this file. And then there are some plotting as well happening here. So this is a log plot. There is also a linear plot. Here, yeah. But now if you go into the data section, you could also see that there are some more data which has been collected from this file. There's some information related to the source of the X-ray tube, and then there are some additional quantities here for the results and all. So yeah, this way you can actually automate this entire process of creating templates and filling them up with some file that you want to parse using plugins. And I'm not sure if I have time to show the explore section here. But maybe I can quickly show so our upload is basically ready. And these are all the entries that we created. But now let's think in the long run, you have like 20 of these uploads and you just want to make a meaningful search on one of these entries. Then it will be a really mess if you start exploring these uploads and take a look at each of these files. So NOMAD provides a really intuitive way to actually search across your entries. And to do that, we simply go in the Explore tab here, and we select one of these apps. Let's say we select the ELN app here. And then it allows you to select a bunch of filters. And let's say that we go into the electronic lab notebook, and maybe we want to pick up the ELN process that we or the experiment that we just created. So we select this, and we have our experiment ELN entry. Or maybe you wanted to do this search based on some elements. So maybe you want to select gallium and oxygen, and it will again show you the sample which has these compositions. But yeah, that was it from my side. Now I'll hand it over to Andrea.
So I will just quickly wrap up what Sarthak said. So thank you, Sarthak, for this very nice demo of the function we have available in the ELN. I hope you can already see my slides. If not, you can just shout. And okay, so what did we just see? So it was a nice demo on the functionalities that we have available in the ELN, shown either through the built-in classes, that is just something we can instantiate and is already available in NOMAD, or we can even extend these classes writing a YAML file. Which are the highlights of the functionalities we usually can benefit of in the ELN? Basically, we saw that we can create different archives depending on how we want to structure our data from the experiment, and then we need to master like all the possibilities of referencing, like the archives, like with these referencing capabilities. And this is basically allowing us to collaborate with the other colleagues, because we can imagine that the synthesis process was made in one lab while the characterization was made in another lab. And so this is basically allowing us to have two different browsers into different laptops open, and then the upload that is being created can be shared with the colleagues. And so one can fetch the data that was recorded by someone else. Also, we saw some of the visualization tools that I was mentioning before. So we can navigate these archives very conveniently. We can see these workflow graphs that are being drawn automatically once we instantiate more pieces of our data. And yeah, so that was basically it. So in our repo, you can find a step-by-step documentation on what Sarthak just showed. So if you want to go through that again, you can just take a look to the README file in the part 2 folder. So the next part was like using a YAML. So this is also a pretty quick way of extending the already available schemas. In this case, we saw Sarthak generating or adding 2 new data fields in initial temperature, final temperature, that at the beginning we are just written in this rich text edit quantity. So what do we gain from this? Writing 2 dedicated quantities for that is making this information machine readable. So we can access this initial and final temperature through an API call. And so when the quantity of our data is scaling, this is very convenient to fetch homogeneously whatever is available in our repository. Again, to take a better look to this, you can go to the tutorial 8 and see our examples on this GitHub repo, or even in the YouTube channel. There are some more videos about that. So the last part of this demo was showing basically one of the plugins as we developed it. So in this case, it was an XRD plugin. We have a dedicated repo where this file, where this code is contained. If you want to take a look at that, even clone it and maybe load it in your NOMAD Oasis. And what is available in this plugin is 3 readers already. So we can read files from Rigaku, from Panalytical, and from Brooker. And as you saw, some of the metadata are extracted. And so we are constantly working to extend the set of metadata that is being automatically understood from the raw file. So this is the kind of machinery that the plugin is offering. So we just saw how it should look like at the end. And yeah, we will show you also later how to develop your own plugin.